Yes, hello. Can you hear me? This is Melissa.
Yes, we can hear you. So I'm really excited for this talk as we see the S3 buckets keep coming up and up. It keeps coming up in almost every talk. And also I noticed in that same Verizon DBR that I was reading last weekend, 22% of all breaches, which was number 2 on their list, are configuration errors. And it seems like S3 seems to be a very popular misconfiguration. So I'm really excited to see what you guys are going to talk about. I heard you guys had one of the best sessions last year at the Cloud Security Summit. So I'm really excited for this. So Melissa, you sound good. Lily, are you there as well?
It would help if I unmuted myself. Hi.
Oh, hey. All right. All right, I'll let you guys take it away.
Awesome. So good morning, everyone. I think it's pretty much morning all around. We're so glad you have chosen to join us here this morning. How's everyone doing? Good, I hope. I have to be honest, I was really looking forward to visiting Texas for the summit, but you know, we do what we can. So who are we? Well, I'm Lily, and I'm a security strategist at Splunk. I get to work with Splunk's most awesome customers, fixing some of their biggest problems in security. If you guys have ever played Splunk Boss of the SOC, that's our very popular CTF that Splunk hosts, and I'm actually one of the primary leads on that CTF. I'm super passionate about advocating for women in tech as well as women in cybersecurity, and I'll be delivering this talk here today with Melissa.
Hi, everyone. My name is Melissa Napoles. I am a solutions engineer, and so I spend my time helping clients put data and architecture strategies into place. And I've found I really enjoy the cloud and cybersecurity space, big and small data alike. And that's really what's brought me here to the SANS Cloud Security Summit. So for those of you who are on with us right now, we're glad you're here and we're excited to get started.
So many of you are running or are probably thinking about running part of your infrastructure in a public cloud environment like Amazon Web Services or Google Cloud or Microsoft Azure, right? And you'll definitely need some kind of backend storage solution. We're going to be focused on AWS here today, but these concepts can be extended to all of the cloud platforms and providers. One of the storage services that AWS offers is called Simple Storage Service, as we all know, is called S3, right? So the typical things you might store are objects and files such as the source code, we just talked about that a little bit, certificates and passwords and web content, databases, and much more. One of the biggest challenges, as we've just heard and during the intro in the DBIR, is that with cloud security, people often are unpredictable and prone to being human, right? And that's where the expression human error comes in. So we often see security incidents happen that are simply errors made by well-intended users and employees. And while they mean well, these errors can and often do inadvertently put organizations at risk. So when you create a new S3 bucket, you have a bunch of configurations and settings that you have to go through. These configurations and settings can seem confusing to someone who's encountering the first time, and then therefore misleading or leading to misconfigurations. These S3 misconfigurations have now become one of the most common and widely targeted attack vectors across all industries, which is why we've chosen to talk about it today. And Dave just mentioned this as well. So what we hope you will walk away with at the end of this talk is an understanding of the anticipated and unanticipated fallouts of misconfigured S3 buckets, some of those key data sources in AWS that will help you identify such misconfigurations, and how to pivot across them during an incident investigation. But before we get started there, let me first recap for you what we discussed last year. We kicked off the talk with an infrastructure comparison of on-premises solutions to the AWS services. Then we talked about security and compliance being a shared responsibility between you and AWS. So as a reminder, AWS is responsible for protecting that infrastructure that runs all of these services, offered in their AWS cloud, but your responsibility is driven by those services that you select. And just like with on-premises, you would need to harden your systems, you have to test for vulnerabilities, and you apply strong network policies, for example. We follow that up with working with that AWS data to help you detect malicious activity, focused really around CloudTrail and how it's extremely valuable for security operations. And then we concluded the talk with best practice checks and how AWS Trusted Advisor helps you observe some of those best practices. One of those best practices is around S3 bucket permissions. So let's dive into that a little bit. What's the big deal with S3 bucket permissions anyway, right? Obviously, it's been making headlines, but personally, if you're just venturing out into the space, it's definitely something to pay very serious attention to. As I previously mentioned, human error is often the culprit of misconfigured S3 buckets. So if you're vulnerable, attackers get full access to your S3 bucket, thus allowing them to download, upload, overwrite the files. It doesn't really take much for an unskilled person to search for a misconfigured storage bucket and abuse it. So we're going to walk you through a very real world example of just one thing that could happen when S3 buckets are left open for the world's taking. On the right-hand side, under best practices, when you consider the shared responsibility around S3 service specifically, Amazon has set that default setting on those buckets as private, as Dave also mentioned, right? That thus ensuring your security out of the box. But you are responsible for how you utilize that service, including properly configuring the access policies to your S3 resources, ensuring proper encryption, proper storage settings, performing the overall threat analysis and defense, and the security of the applications that ultimately access the data that's stored within. Therefore, if a bucket becomes public, it means that a user made a change somewhere along the way. So these terms probably sound very familiar, and they're often part of the fallout of one small configuration having a cascading effect that then leads to a loss of many of these types of data, or any one or many of these types of attacks. The fallout, though, as we previously mentioned, when S3 breaches first started happening, had mostly been a loss of data, like personally identifying information, huge databases of usernames and passwords, birthdays, social security numbers, and so on. That would maybe just end up somewhere for sale or even for free. And that's because those have typically been limited in scope to just global or world readable permissions. But what if an attacker could read that data and overwrite that code? And Dave also just touched upon this. We just can't harp on this enough that proper implementation of the shared responsibility model can help you minimize these types of data breach incidents due to misconfigured services. In addition to those few names that Dave just showed, security researchers are constantly discovering open, unprotected S3 buckets containing sensitive data. Here are some other names to go along with inadvertent S3 breaches. Many of these, as you can tell, are even common household names or common apps that we're using every day. Many of these do date back to something like 2016 and 2017. So obviously the problem hasn't gone away. I mean, I know I wouldn't want to be that next Verizon that exposes subscriber data, including sensitive corporate information due to a simple human error that inadvertently exposed S3 bucket publicly. And I'm certain you probably wouldn't either. Oh, wow. Sorry. My mouse just took a spin. Super sensitive. Okay. There we go. So since one of those common errors is that a user accidentally makes an S3 bucket public, we thought we would use this as a real world example as well. In fact, not only has the bucket been made public, it's vulnerable to reads and writes and becomes susceptible to cryptojacking, to a cryptojacking attack. So just like Dave mentioned in the LA Times, for the LA Times in 2018, we're actually going to kind of elaborate and unravel the story for you and see how it actually happens in real life. Now, since S3 can be used to store pretty much anything, you can even host a website using Amazon S3 and store all the elements on that website in an S3 bucket. Amazon provides a rich repository of reference architecture diagrams, and this here is an example of an AWS cloud architecture for web application hosting. If you'll notice over by the letter H, over on the right-hand side, towards the far right, there's an S3 bucket icon depicted there, and it would store things in a web-hosted architecture, such as backups or static assets like your images or your videos. You would think that I'd be better with Zoom controls. I apologize. Really? Okay. Sorry about that. I can't seem to get my Zoom under control here. Okay, now that we've reviewed web application hosting, let's talk about how a misconfiguration of that S3 bucket, which holds this web content, could lead to something like cryptojacking. You've probably heard of cryptocurrencies such as Bitcoin, Ethereum, Litecoin, etc. So in this world of virtual currencies, mining is a validation of these transactions. The transactions are validated using complex hashing algorithms that typically only powerful compute-capable hardware can solve. Successful miners get that cryptocurrency as a reward and an incentive to pay it forward and contribute back to the processing power of the network. Now, crypto mining isn't illegal per se. However, the illicit method of crypto mining is called cryptojacking. That's when someone's doing it behind your back, right? There's miner software or a script of some sort that utilizes your device or someone else's device that isn't theirs for crypto mining activities, which then effectively hijacks the victim's resources to perform the mining activities. You might be asking yourself, well, how bad really is cryptojacking and how do I fall victim to it? Well, you could become a victim of cryptojacking through normal phishing tactics or by clicking a malicious link where code or software gets installed. Simply visiting certain sites, just like in the case of LA Times, could potentially lead to cryptojacking as well. In the case of browser-based crypto mining code, the adversary would compromise the web server and sneakily add in mining code that mines cryptocurrency whenever anyone visits the website or renders the infected ad pop-up. Now, no code is actually installed or stored on the victim's device, and the intent is not data exfiltration. However, it does take over the resources of the client device. Either way, the crypto mining code would work in the background as unsuspecting victims would use their computers normally. Over on the far right, or an adversary could take over a public Wi-Fi access point and inject crypto mining content wherever the visitors go. This type of man-in-the-middle attack happened to a Starbucks in 2017 in Buenos Aires. So what's the impact? Well, crypto mining infection could render your websites slower. It could affect your brand. It could affect your employees and their machines, and then they couldn't do the work that they need to. It could incur costs to your organization. Think about it from the context of an electricity bill, or cause regulatory fines, or force you to throw hardware at the problem. Also, that same hole or vulnerability could be exploited by another malicious actor using that public S3 bucket. Now, as for prevention, we're actually going to say that for next year's talk. No, I'm just kidding. If you practice a layered approach to security, right, when you think about an effective line of defense that includes next-gen firewall, endpoint, security analytics, and DNS layers, you then stand a better chance of detecting and preventing crypto mining infections across your network. So here's our real world scenario. Bud, over on the right, he works for a company named Frothly and heads up the IT department there. He even leveraged that AWS reference architecture that we showed earlier a few slides before for web application hosting to set up the customer forum called Brewer Talk. While working from home, Bud here decides to make it easier so that he could work from home, opens up that S3 bucket access policy to allow him to upload and download the Brewer Talk forum code. Bud is super excited about the changes that he's made and asks all the employees of Frothly to check out brewertalk.com customer forum. Now, unfortunately, of course, through all this haste and excitement, Bud forgets about the permission changes that he made and inadvertently leaves the bucket open after the maintenance completed. So here's one of the employees at Frothly who goes to Brewer Talk forum and starts to notice that their computer fan's constantly running and notifies Bud. Now, unbeknownst to Bud, here's what's been happening during the time that S3 bucket was exposed publicly. One, an attacker found the public bucket and downloaded everything inside it, including the code for Brewer Talk forums. A short time later, the attacker uploaded a new version of the code, but slightly modified this time to include a client-side coin miner. Two, a burst of web traffic to Brewer Talk causes a new EC2 web server instance to spin up with the coin miner. Then three, the miner then runs in the browser of every client endpoint device that visits the Brewer Talk forums. Now that the scene has been set, Melissa will walk you through Bud's investigation.
Okay, so I think we're switching over click controls. I'm going to quickly test that just before we continue. All right, I'm controlling Emily's screen. Let's see if this works for me. Okay. Excellent. All right, so you now know what the attacker did, the cryptojacking attacker, but how does Bud know what he or she did? What you're going to see in the rest of the presentation here is an example of how one might detect a cryptojacking attack like this. And really what we hope you take away is a fewfold, but most importantly, again, a real example of how one pivots between data sources, thoughts, information really, to put a real life story together that they can solve, because that's half the battle, right? What data sources of the many AWS services that produce data out there are the ones worth inclusion in your understanding if you don't even know where to start? And lastly, only one example of many examples as to why it matters so much, if you haven't gathered that already by the summit, why it matters so much to care about any misconfigured S3 buckets. All right, so we know Bud sent out an email asking folks to check out the new website and let him know their thoughts, and in doing just that, an employee's computer fan starts running intensely. Like most of us would normally do, he or she goes to check the resources on the computer and finds that the website that Bud told them to go to is in fact the very thing that's making this computer's fan run on overdrive. So Bud is called over to check things out. And in doing that, he realized that there's miner code running. He knows he didn't place it there, so how did it get there? And suddenly he remembers the work he did in changing the S3 bucket permissions around. Ideally, he'd be alerting for this kind of stuff, having a fail-safe of sorts, right? But next time, Bud, we've all been there. So he wonders, okay, are the changes I made to the S3 bucket related in some way to this coin miner code that I'm now seeing? And he asks himself, where do I even begin in figuring that out, right? Because sometimes our greatest kryptonite is analysis paralysis. I've got all the data, I've got all these great tools, but where do I even start? And so throughout this storyline, you may hear me say we, and when I do that, I'm indicating that we are Bud. And so if I switch between those, just know that that's where that's coming from. And the questions that we'll start with focus on understanding, okay, so what permission changes happened on the S3 buckets for sure? I think I know what I did, but for sure, what did I do? To what degree have those bucket permissions changed, and have they been made public to the world to any degree, or even internal folks that shouldn't be able to see it, and what activity has occurred with that bucket since? That logic sort of falls into two steps. First, reviewing S3 bucket permissions so that one can say ad hoc, look for the activity or alert on this activity, and second, auditing S3 bucket access and activity. And in doing those two things, you'll see that we back into AWS CloudTrail logs and S3 access logs. And if you don't already, you'll come to understand why they matter and why you should know about them. And so that's where we'll start. Okay, so when thinking about what you should be looking for to insinuate permission change on a bucket, like global public access in this case, you want to be looking at your CloudTrail data. And the areas highlighted here are the areas that you want to focus in on. Here we have a JSON file in Splunk, but what's important here is not so much the analytics tool as much as knowing what to even look for in your CloudTrail data. And so you'll see here we focus on the event name that tells us what occurred, an ACL, access control list, permission change occurred, the event time, what time did it occur, the request parameters that tell us, okay, an ACL permission occurred, but what type occurred? And in this case, the type that occurred allows any user in the world, if they're smart enough, right, to read or write from this bucket. And speaking of the bucket, we also see the bucket name that tells us the changes that happen to the Frothly web code bucket in particular. And lastly, the ARN, the Amazon resource name that tells us who made this change, in this case, Bud. So at this point, what Bud is doing is reconfirming what the change that he knew he made to ensure it wasn't, in fact, something different. And to understand what activity occurred with our S3 bucket, we're going to want to pivot to looking at the S3 access logs for that specific bucket of Frothly web code. And the fields you want to key in on the S3 access logs in this case are those that you see here, specifically who's making a request, by what IP, is it a recognized asset of ours or not, was the operation an upload activity, a download activity? If it was, what exactly was placed in or taken from the bucket? What were the bytes sent in that event? So that when we see the anomalous activity, if any anomalous activity, we can further investigate. And when we take a closer look, we in fact see just that. Shortly after the bucket was made public, we see upload activity of a text file by an unidentified IP. And when we download that file, we find it to kindly warn us that we have a bucket that people shouldn't have access to out there that have access to. And with barely any time to react and do anything about it, we noticed that there was odd activity shortly right thereafter. So the succeeding set of activities indicate downloading of all contents in that S3 bucket from that unrecognized IP, which at this point includes the text file and a tarball called Frothly HTML memcached, followed by re-uploading of that tarball. What's abnormal is that at first glance, it might not look like anything weird, right? But if you take a closer look and you're really keying in on all the context that these S3 access logs provide you, you notice that that tarball that's newly uploaded is about a little over 19,000 bytes larger than the original. So now imagine Bud was not both the IT admin and the incident responder. As the incident responder, he may need to confirm the purpose of that tarball, which is what we're going to go through next year. In trying to figure out what that tarball is doing, perhaps we open it, talk to someone about it to try and figure out what it is, but most logically, if we can't do those things as fast as we might like, we're likely going to reference any operational documents that we have that help us understand, okay, I think I know what this file is doing, but for sure, what is this file doing? In looking at these resources, we narrow in on this one. And so this is the AWS Architecture Diagram that has been referenced a few times throughout the presentation. This is something that's publicly out there, and it's a very common strategy for deploying AWS resources. So we see our web servers have an ELB in front of them and are in an auto-scaling group that pull from the S3 buckets. And here we realize this tarball is our web server code, or we think it is, which makes sense because our bucket name is in fact Frothly web bucket. And if you haven't already gathered to this point, you know, the reason this is scary is because this is a very real standard architecture. So one little mistake on a bucket misconfiguration, and depending on what your web servers are pulling and the strategy that you're employing with what you put in those buckets, you could be in a really bad spot. At this point, we know our bucket was made public for the world to see. The tarball was downloaded and re-uploaded as a bigger size, and we know it now represents our web server code. So from here, what next? Well, we might ask, why was the tarball re-uploaded as a bigger size? What effect does it have on us, if any at all? And who did this? Does it have anything to do with the coin miner code that was pointed out to me and found? Well, what we find in these questions is that it takes us through confirming the purpose of the original tarball, looking for the potential fallout of that new tarball, and understanding if it has anything to do with the coin miner code. Asking these questions takes us through endpoint logs, Elb Access Logs, and back to CloudTrail logs. So similarly, as you've started to familiarize yourself, get intimate with what the CloudTrail logs look like, what the S3 Access Logs look like, we'll do the same here moving forward with just one example of an endpoint log and then AWS Elb Access Logs. Okay, so in looking through where the tarball file name appears in all of our other data that we're collecting, we find reference of it in our cloud init data source, where we learned, if we don't already know that cloud init can be used to initialize a cloud instance automatically. And from the cloud init data, we gather what appears to be downloading of the tarball file from the S3 buckets onto the web servers as a part of a new server startup. So at least we now know the new, larger, possibly bad tarball hasn't been pulled unless a new web server has been launched. But our web servers autoscale. So has a server or servers been spun up as a result of autoscaling with the latest tarball? If so, how many? What is my fallout here? And when? And by who? At this point, when we think about what autoscaling is really doing here, it's saying when our web traffic gets to a point where we need more resources, spin up more servers. And if you remember our architecture diagram, folks are getting to hit the ELB first. They're going to be making requests of the ELB without knowing it's the ELB perhaps, right? Unless you're somebody who's malicious and you're banking on the fact that somebody's using very standard AWS architecture strategy. So that brings us to looking for odd web traffic, where we may ask questions like, how many web requests have we gotten, by what source IPs, by what source regions, by what destination IPs, and at what frequencies? And are the answers to these questions what I would normally expect to see, or are they weirdly off from what our normal is? And in trying to understand if any servers did in fact autoscale post the uploading of the new tarball, we pivot to searching Elb Access Logs, because we know, again, the servers sit behind the ELB based on our operational diagrams, and we focus on the left visual first. We see how many web requests have we gotten. We can see that the IP designated by that burgundy color spun up post S3 exposure, and thank goodness it's only been one server that's spun up. Was the spin up a result of normal traffic patterns, or someone intentionally hitting us over and over, hoping we have auto scaling because they're betting we are following something similar to AWS best practices out there? And coincidentally, they've also found an open S3 bucket. Well, when we look at the web requests by their source, so on the right-hand side there, we see a huge spike from one IP designated by that sort of brownish color. And it's hitting us a ridiculous amount of times at the same time, which is, it's not historically normal for us. So why now, especially right after making the bucket public, and maybe it's from a part of the world we don't normally see requests come from? At this point, it would make sense to investigate things like, what region does this IP come from? And if it's similar to a region tied to any other activity that happened in our S3 Access Logs with uploading and downloading, that is anomalous. That's a red flag that we should seriously take into consideration, as all this happening by the same malicious person. To confirm that the new web server, only one, right? Thank goodness. We're hoping to catch it before it falls out really bad. So to confirm that that one new web server instance was spun up as a result of auto scaling, we look back at our CloudTrail logs for that one new burgundy colored web server's IP address. And we see it was in fact autoscaled by the user agent field that's called out here. To confirm whether this new web server was in fact deployed with the new, larger, super skeptical looking tarball, we go back to the S3 Access Logs looking for the web server's IP to see if it pulled the new tarball. And in fact, it did. We can see that here. So there's now like a number of to-dos on Bud's list, right? He's got to lock down the permissions of the bucket. He's probably got to restore the web server code back to a known good copy. So now that Bud knows this, now that he knows he's left the S3 bucket that stores a web server code open for the world to see, and someone in the world or someones in the world took advantage and got lucky, Bud made a mistake, they could exploit, he ensures that the bucket permissions are locked down properly, and not just by going into AWS console and updating the permissions, but also using the data to confirm that that is in fact what happened and nothing else accidentally happened. And he reverts the website code to a known good copy and checks that it is in fact all that was loaded into the bucket after the fact with the data. So there are so many ways one could tackle this investigation and any investigation really, right? It's almost like organized chaos where the organization presents itself in the key nuggets that help us string a story together as many times as we may go forward and backward and upward and downward until we keep making little steps forward. In this case, those key nuggets, no matter how many times you go backwards and forwards in any other way, those key nuggets remain the same and are things like the bucket name, whose permissions were altered, that we found in the CloudTrail logs and filtered on in the S3 Access logs, the bucket content or the bucket context of the bad actor, uploading and downloading that we found in the S3 Access logs and pivoted in operational documentation on. The operational documents that told us that a bad actor intentionally was trying to spin up potentially resources for their crypto mining activity and how it would hit the ELB first, and then ultimately the ELB activity confirming our suspicions. In remediating this, Bud locks down the bucket permissions, restores the web code, and is back in the safe zone for just a little while longer. So there are many cybersecurity detections worth focusing on in the world of cloud, as we've seen here throughout the summit. But one of the key takeaways we hope you all take away is don't forget about the low-hanging fruit, as they say, right? Make sure to consider the easy cyber detections that can have a hugely positive or catastrophic impact on your organization, right? These are not even the complex ones, but they can change so much. In fact, I'd argue sometimes they could impact your organization more than some of the other complex detections. Always be monitoring and alerting for these things. Don't just look for it after the fact. Thirdly, of the myriad of data sources one can back into in the world of AWS, when it comes to activity around your S3 buckets and you don't know where to start with access logging and activity. More specifically, CloudTrail, S3 Access Logs, and ELB Access Logs, just to name a few, right? So get out of that analysis paralysis and just go ahead and get real super up and close to those three data sources in particular when it comes to the world of S3 buckets. And last, but certainly not least, keeping your data secured in a cloud world is still very much equal partnership and responsibility. And that's all, folks. Lily and I just want to thank you for your time and thanks, Sam, for letting us share some nuggets of insight with you. We're here for questions and we'll be hanging around in our Slack hallway for 30 minutes after our end time here. But thank you so much for your time.
Yeah, and I apologize.
Awesome.
Good morning, good afternoon, and possibly good evening to all of you, because normally we would have this in Texas and it would have been good morning. So I apologize. That is very naive of me. So.
No, believe me, I think all the days are actually blending together. The hours are blending together as well, Lily.
It's true.
So, so hey, Melissa and Lily, thank you guys so much for your presentation. That was awesome. Always great to hear from you guys. We do have a question that came in from Christopher Hughes and also said, hey, that was a great walkthrough by Melissa of reviewing cloud native logging for incident response. The question is, how exponentially difficult does the investigation get when the customer didn't maximize the use of the cloud native logging capabilities?
You want to start, Lily, and then I'll add on?
Sure. I assume cloud native logging capabilities would be some of like the examples we showed, the CloudTrail, a look at those access logs, et cetera. The challenges that I have had where I am not able to aggregate that data is the pivoting, right? Pivoting between going into my AWS console and trying to go from S3 to CloudTrail to whatever other logs that I'm looking for, and doing that correlation by hand or what do you call it, manually, right? Having to do that manually versus being able to have some sort of data analytics platform that can help me accelerate those correlations. And also one of the other challenges I tend to have is retention. When I want to, depending on the investigation timeframe, if I've had to go back to a certain time where maybe the logs aren't there, or that they've rolled off, or I didn't enable it at that moment in time, I don't have access to that information. And therefore it does, to me, it has become very difficult to backtrack my ways through an investigation for those reasons. Does that help answer the question? Is that the question that was being asked? I just want to make sure.
I want to add one thing to that. So there's only so much you can do with what you can't see, right? So you need to be collecting something. So that's to say, if you're not collecting data, even in the AWS console itself, and not taking it to another analytics provider, there's only so much you can do. However, you back into, well, is there a strategy I could have around different types of data, right? There's logs, and then there's metrics. And I almost think of, and this is not maybe the proper way to say it, but metrics are like a tiny bite of the log, right? So there's a strategy you can employ such that you're using the metric versions of your log format first to get the density of what you need, but without the volume. And when you see really crazy, abnormally scary things, get right into your logs. And that's not to say you want to use that strategy for every single data source, right? Use it where it makes sense. But I almost imagine, like, if you think like a 2D graph, and your x-axis is the efficiency from a cost perspective or from a utilization perspective to gather said data source, and the y-axis is the time it takes to actually search that data and get those results. It's like you can have a strategy where you've got logs, metrics, and even other types of data sources that are emerging now that allow you to sort of take advantage of at least starting small if you can't start big with logs. Sorry, go ahead. It sounded like someone was going to talk there.
No, I think the other thing to add is if you're not leveraging the native logging capabilities, there's no way for you to understand the baselines and what's been normal and what's now abnormal, right? So I would say that certainly would make an investigation hard if you don't know what's normal and compare it to a incident or a suspicious moment in time, because you have no historical analysis to revert to.
Yeah, and I think I would agree with you guys. I think, first off, the volume of event data that's being generated within the cloud to begin with, it certainly doesn't make it easy to to distill if you don't have a lot of those cloud native logging services enabled and so forth. I mean, even with those enabled, you're going to need some additional overlays to figure some of that out. But again, I think it's always good to go through these types of scenarios and walkthroughs to think about how you would develop those use cases and workflows and so forth, because otherwise, you're just sort of swimming around in logs, and that doesn't do a whole heck of a lot for you. Okay, well, there's one question that came in from Razi. Razi, I'm actually going to ask you if you wouldn't mind just to post that over in the Slack channel. He's asking about whether anybody knows about reports available that show things like browsers and usage in crypto mining attacks. And I'd sort of like to open that up to the collective wisdom of the folks that are attending, just as much as to both Lily and Melissa. And it's also actually time for us to take a break. So this is perfect. Again, thanks so much to both of you guys for coming and presenting. Always, again, a pleasure to hear from you guys and get your perspective on some of these types of things. But with that, I'll go ahead and call us until the 10 till the next hour. And we will see you guys back for some more awesome talks. Thanks, everybody.
Thank you so much.